Explain what you understand by a population. A population is all the required data. Question number B, statistic. A statistic is a random variable. It is a function of the sample which contains no unknown quantities. A statistic is the calculation made from sample, and it is mean, standard deviation, median. All these things are called statistic. It can be used as a random variable, and for calculating the statistic we don't need any unknown quantity. The next one is question number C. A researcher took a sample of 100 voters from a certain town and asked them who they would vote for in an election. The proportion who said they would vote for Dr. Smith was 35%. State the population and the statistic in this case. The population is what you need. All the required data is all the voters. So the population is the voters. So all the required data is population. Now the statistic is the calculation that you make. It's a calculation. So here the proportion, the statistic is the proportion. Next question, explain what you understand by the sampling distribution. So sample distribution is a probability distribution where the random variables are the statistic and the probabilities are given below. So that's called a sampling distribution. It is the probability distribution of those voting for Dr. Smith. Remember, you have to give context. If you give no context, you get no point from all the possible samples and their probabilities. So each and every random variable and their probability, that is the sampling distribution. In question number 2, Bhim and Joe play each other at badminton, and each game independently of all others, the probability that Bhim loses is 0.2. Now you know it is either going to be binomial or Poisson distribution. This is probability 0.2. It has to be binomial distribution. So the probability is given and this is also given. So this is n. So find the probability that in 9 games, so that is n. Whenever you see probability, it has to be binomial. Exactly 3 games. So how do we start? We always start by defining the random variable. X equals to number of Bhim loses. So number of games Bhim loses, that's the probability of success, and the distribution is going to be n is 9. There are 9 games and the probability of success is 0.2. Success or failure is not about a good or a bad thing. Whatever is given information, that is success. Exactly 3 of the games Bhim loses, therefore probability of x equals to 3. So this is discrete. It is going to be probability of x is less than or equals to 3 minus probability of x is less than or equals to 2. Look up the table and write down the answer. The next question, the probability that Bhim loses fewer than half of the games. Fewer than half, that means if they play altogether 9 games, fewer than half means x is less than 4.5. Since this is discrete, less than 4.5 is going to be x is less than or equals to 4. That's it. So look up the table. That's it. After that, we are going to have Bhim attends coaching sessions for 2 months. Okay. After completing the coaching, the probability that he loses each game independently of all others is 0.05. So the probability now is very low, 0.05. Bhim and Joey agree to play a further 60 games. So now now the probability of success is very small and the value of n is large. Remember, larger than 50, that is means this is not in the table. Calculate the mean and variance. So mean means expected value. Now if I write EX, it would be wrong because X is for N is 9, P is 0.2. So be careful about that. Instead of writing EX, it's best to write just mean and variance. So don't fall into this trap. Mean equals to NP and variance equals to NP 1 minus P. This is 2.85. Okay. The next one, use a suitable approximation to calculate that beam loses more than 4 games. So more than 4 games means it has to be, first of all, we have a new distribution to do, because it is not possible to do the sum under this distribution because the distribution has changed, and they always mention this using a suitable approximation. So we can use y. Since both of them are same, you might not write this all over again. If you want to, you can write it. Number of games beam loses. So it is going to be y 60.05. That means we have to do a distribution. Now you can see the mean and variance, they're close to each other, so that means we can definitely use the Poisson distribution. Lambda is 3, so using Poisson approximation, so we can write the alphabet A, Poisson, lambda is 3. Now we have to find the probability loses more than 4. Let me write over here. Probability of A is greater than 4. That means probability of A is greater than or equals to 5. That means 1 minus probability of A is less than or equals to 4. The answer is 0.1847. A rectangle has a perimeter 20 centimeters. So whenever you read that, you understand this is neither binomial nor Poisson distribution. This is a uniformly distributed. So when you do this uniform distribution, you have to understand this is a bit irregular. Uniform distribution is not something that we get in all of the exams. So what they have given, we have a rectangle. So this is a rectangle. One of the side is x. Suppose the other one is y. So the length x centimeter of one of the side is uniformly distributed. So this is uniformly distributed. So we can say that the perimeter is 20. So x, if this is x, and this is y, this is y. Perimeter means total length. So x plus y plus y equals to 20. That means 2x plus 2y equals to 20. That means x plus y equals to 10 if I take 2 common and divide. So now we are talking about this one, x. If x is between 1 and 7 centimeter, if this is the interval for uniform distribution, so if x plus y is, if two of the sides is together 10, if one side is 1, if one of the side x is 1, then the other one must be 9. So, and the other way around, if one of the side is 7, if both of them together is 10, it should be 3. So the distribution is 3 to 7, and the PDF is going to be, the rule is 1 by b minus a, which is 1 by 6. So the sketching for this continuous uniform distribution, this is x, this is fx. So the limit is going to be from 3 to 6, and the PDF is 1 by 6. Since it is uniform, it is going to be like this. Okay, now find the probability one of the longer side is more than 6 centimeter long. So the probability for more than 6, so assuming we are talking about x, because one of the side, find the probability that the length of the longer side. Now we do not know which side they're talking about, either x or y. So suppose we are talking about x, so more than 6 means this one. If we take this as 6, so this to this is 3, so this is the area we are talking about. So the probability of x is greater than 6 is equals to area, length into breadth. So this is 6 to 9 is 3, and this is 1 by 6, so this is half. Now one of the possibility is, if this is more than 6, it could either be x or it could be other side is 6. In that case, x is going to be 4. You have to remember, if this is together is 10, if this is 6, then this is going to be 4. So, or it could also happen, so probability of x is less than 4. In that case, if it is less than 4, if it is here, so this is the probability we are looking for, which is 3 to 4 is 1, and this is 1 by 6, this is 1 by 6. Therefore, probability of more than 6 is either half or 1 by 6, which is 2 by 3. This is irregular, but this is extremely irregular sum. This is not something that you do in every paper, but this is something you might want to review. This is a general continuous random variable sum. So we have a CDF given, we have to find the median. The formula is CDF equals to 0.5, so fx equals to 0.5, therefore 4 by 9 x square plus 2x minus 3 equals to 0.5. Let's solve this equation. So this is equals to 0.5, and we solved a quadratic equation because it was given that the median has to be 3 significant figures. So we have two values. How do you choose the median? So you can see here that the limit is from 1 to 1.5, so it has to be between 1 to 1.5. That's why this is the median. The next question, find the PDF. You know the formula for PDF is we have to integrate. For finding the PDF, for finding the CDF, we need to integrate the PDF, and for finding the PDF, we need to differentiate. We need to break it down. D by dx of fx. So this is going to be d by dx of 4 by 9 x squared plus 2x minus 3. Now you can just keep the constant outside, it's alright. Just differentiate whatever is inside. So this is 2x plus 2. So you can take the 2 common, and it would be 8 by 9 x plus 1. Now this is not done. You have to define the PDF. To define the PDF, you need an expression here, which is 8 by 9 x plus 1, comma, the limit is the same as the CDF, x to 1.5, and you need to write here 0 otherwise. Question number C, find the probability. So find the probability of x is greater than or equals to 1.2. Remember, if you have the CDF, you can find the probability if it is less than. So since this is continuous, it is the same as less than 1.2. It makes no difference. In continuous, it makes no difference. So 1 minus f 1.2. So now we can just put the value and find it. So the CDF expression is 1 minus 4 by 9 1.2 square plus 2 into 1.2 minus 3. So this is going to be 0.3733, so that makes it 0.6267. The next question is, a camping lantern runs on 4 batteries. So first information is 4 batteries, all of which must be working. 4 new batteries are put into the lantern. Find the probability that the lantern will still be working after 1.2 hour. Now if you see this and this matches. The previous sum and this sum matches. So this is an irregular sum, and this sum can be given at the end of any sum. It's a binomial distribution that needs to be made. So the probability of success is after 12 hours. So P equals to 0.6267, N is 4. So this is that the battery is working. So we can use the alphabet Y, number of batteries working. So now they have given another number here, 4 batteries are working. So this is the N and this is the random variable. So therefore probability of Y equals to 4. So for doing this particular sum we have to use the PDF, because this is not in the table but it is within the limit of the table, but this is also within the limit of the table, so we have to use the PDF. We cannot use approximation here, and in approximation it will be mentioned use the approximation. So therefore this is equals to NCR 1 minus P to the power R, this is 0.6267 P to the power this, and this is equals to 0.154. A company has a large number of regular users logging onto its website on average. So that means on average means this is Poisson. Every hour 4 users every hour fail to connect to the company's website at their first attempt. Okay. Question number A. Explain why the Poisson distribution may be suitable model in this. That means properties of the Poisson distribution. So events, it has to be in context. Customers or users, they use the word users. Users fail to connect singly, independently, and at a constant rate. Question number B. Find the probability that in a randomly chosen 2-hour period, so the first information was every hour, so this is for 2-hour period. So let's start with 2 hour. So number of failures, meaning failure to connect, or number of users failing to connect per 2 hour. So I'm starting directly with 2 hour Poisson. So every hour is 4 user, 2 hour means 8 user. So therefore probability, this is B1, numbering is very important. All the users connect. So how many fail? None. Okay, so this means probability of X is less than or equals to 0. That means 0.0003. Question number B2. At least 4 fail to connect. So at least 4 fail to connect, that means more than 4 people or equal to 4 people fail to connect. That means 1 minus probability of X is less than or equals to 3, 1 minus 0.0424 from the table. If you have to look up the table where lambda is 8, then if you subtract 0.9576. Now the next question, question number C. The company suffered from a virus infecting its computer system. During this infection, it was found that the number of users failing to connect to their first attempt over a 12-hour. Now notice this, 8 hour, 2 hour, now it is 12 hours. So the random variable is going to change. And 60, what does this 60 mean? The number of users failing to connect. So 60 people fail to connect. So this is the random variable, number of users failing to connect. They have given this to information. Okay, let's read the question now. Using a suitable approximation, test whether or not the mean number of users per hour who fail to connect at their first attempt has increased. So hypothesis testing h naught lambda equals to the original information 4. Always read the first line for h naught, and increase means lambda is greater than 4. So this is the first hypothesis testing, always based on the first line. Now we have to find the probability. To test this we need the distribution, so distribution is for 12 hours. So y, number of users failing to connect per 12 hour. That means the distribution is, if it's every hour is 4, so 12 hour means 4 12s are 48, and the random variable is 60 people failing to connect. So that means matching with h1, probability of y is greater than or equal to 60. Obviously we have to use the distribution because this Poisson distribution cannot be used because the value of lambda in the table is up to 10. So using normal approximation, so we know mu equals to lambda, which is 48, and sigma square is also equals to lambda. So the distribution is, let me use the random variable a, so mu comma sigma squared. Therefore y is greater than or equals to 60. Now for the continuity correction, so if this is 60 and we need greater than, so this has to be 60.5. so probability of y is greater than or equals to 60.5. now it doesn't really matter anymore, we have to do the z-score. So probability of z is greater than 60.5 minus mu is 48 divided by sigma is square root of 48. That makes it probability of z is greater than. So after the calculation, so we get 0.0359. that means it is significant because it is within 5%, 0.05. it is significant. If it is significant, then you have to reject h naught. So the context was, so the company suffered from a virus infection. During this infection it was found that the number of users, they are not number of users per hour who failed to connect at their first attempt has increased. Yes, number of users who fail to connect has increased. A company claims that a quarter of the bowls sent to them are faulty. To test this claim, the number of faulty bowls in a random sample of 50. Okay, so 50 is the random sample, so obviously this is going to be binomial. Okay, give 2 reasons why a binomial distribution may be a suitable model for this faulty bowls in a sample. That means the properties of the binomial distribution. So there are 2 outcomes: faulty or non-faulty bolts. This is one of the properties, and the other property is the number of trials are fixed. So the number of faulty bolts are fixed. Faulty bolts are fixed. So that's it. But remember, you need to give the sum in context, otherwise there will be no points given. Okay, using a 5% significant level, find the critical region for two-tailed test of hypothesis that the probability of a bolt being faulty is 1/4. So the probability of bolt being faulty is given. The probability of rejection in either tail should be close to as possible 0.025. Okay, it is critical region, meaning hypothesis test. So H naught probability is 1/4 they have given. H1 probability, this is critical region two-tailed. Two-tailed means not equals to 1/4. So the distribution is going to be x equals to number of successes, that means number of faulty bolts, and the distribution would be n is 50 and p is 1/4. So 50 1/4, 1/4 is 0.25. okay, so we want to find the critical region. So here, if this is critical region C1 and this is critical region C2, so less than probability is 0.025 and greater than probability is 0.025, that means significant level, if you add it up, 0.05 or 5%. so one of the critical region is x is less than or equals to critical region 1 is equals to 0.025, and x is greater than or equals to critical region 2 is 0.025. so we have to find the value of C1. So we need to look up the binomial table. This is the binomial distribution table where n is 50 and p is 0.25. so when we look under, we are looking for 0.025, so we don't have 0.025. the closest is 0.01 because 0.04 is farther away. This is 0.01, so we're looking for the random variable C1. so this is 6. So that means for probability of x is less than or equals to 6, this is equals to 0.0194. therefore C1 is equals to 6. Then for the other one, we need greater than or equals to C2, so we can write probability of x is greater than or equals to C2 equals to 0.025. since this is discrete, it would be 1 minus probability of x is less than or equals to C2 minus 1. remember, in discrete always 1 becomes less, so 0.025. if we just shift the side, it would be x is less than or equals to C2 minus 1 minus 0.025, which means 0.975. so in the table 0.975, the closest is 0.9713. 0.975 means 0.9750. so this is the closest, and we have 18 as a random variable. so therefore probability of x is less than or equals to 18 is 0.9713. 0.9713, yes. so that means, so C2 minus 1 is 18, therefore C2 is going to be 18 plus 1, 19. so the question was it about significant level, was it about critical value or critical region? They said critical region, so we have to write it as a region. so x is less than or equal to, so x is less than or equals to C1, so which is 6, or x is greater than or equals to C2, which is 19. so the next question is find the actual significance level. so this is question number C. so the actual significance level is going to be probability of x is less than or equals to critical level 1, critical region 1, x is greater than or equals to critical region 2. so this is going to be less than or equals to 6. we found it out. less than or equal to 6 is 0.0194. so 0.0194 plus greater than or equals to 19 is 1 minus probability of x is less than or equals to 18. so let's put in the values. 0.0194 plus 1 minus, this is going to be 0.9713. obviously it is going to be closer to 5%. so this is the actual significance level. Next, in the sample of 50, the actual number of faulty bolts was 8. So in this question, this is actually a common question with critical region. So if it is 8, now 8 does not fall in the critical region. If it is 6 less than or equals to 6 and greater than or equals to 19, 8 is somewhere around here. It does not fall in the critical region, so 8 is not in the critical region. So if it is not in the critical region, it is not significant. If it is not significant, we have to accept H naught. So what was H naught? But what was the context? The context was the company said something. The company claims that a quarter, meaning 1/4 of the bowls sent to this are faulty. So the company's claim is correct. So because the challenge was for the two-tailed test, so that is not going to work. So company's claim is correct. Company's claim is correct. The machine making the bowls was reset and another sample of 50 bowls, okay, we have a new sum of 50 bowls was taken. Only 5 were found to be faulty. Remember, this is the random variable is given. So test at 1% level of significance whether or not the probability of a faulty bolt has decreased. State your hypothesis clearly. So we have to do the sum again. Another hypothesis testing, so H naught is the same, 1/4. H1 is decreased. We want to test distribution. We have defined it before x, so that is fine. So binomial distribution is 50, 0.25. 1/4 means 0.25. So the probability we need to test with random variable. So here our random variable is only 5 were found to be faulty. Since random variable is number of faulty bolts, so only 5. So that means random variable has to match with the alternate hypothesis. So x is less than or equals to 5. We look up the table and this is, so 1% is the significant level, so this is significant. It is significant. If it is significant, reject H naught. Now we have to give the context, and the context is the faulty bolts has decreased. So we have another continuous distribution sum. A PDF is given, so we have to explain K and A are positive constants. Explain why A is greater than or equals to 3. So if A is 3, what would happen is the whole thing would become 0. If A is greater than 3, the whole thing would be positive. But if A is less than 3, meaning 2, then the value of A would be negative, which is not possible. So this is the main reason for this. So probability cannot be negative. Probability has to be greater than or equal to 0. So for that reason, since this is A1, probability or PDF Fy has to be greater than or equal to 0. It cannot be less than 0. So Ky A minus y is greater than or equal to 0. That means either y is less than or equals to 0 or y is greater than or equals to A. That means, let's do it a bit simpler way. Let's put the value. We know that the values of y has to be between 0 and 3. So for y equals to 0, the whole thing becomes 0. It is not useful. So y equals to 3. So for y equals to 3, what we get is 3k a minus 3 greater than or equal to 0. Therefore a is greater than or equals to 3. So that is the thing. This is not a regular question. Show that k is this. So this can be done using the regular question, and it is total probability over the limit fy dy. Total probability is 1. So we have 0 to 3 ky a minus y dy equals to 1. So that means 0 to 3, k is the constant, it would be ay minus y square dy equals to 1. So let's integrate this. Let me put the constant k here outside, so it would be a y square by 2 minus y cube by 3 limit 0 to 3 equals to 1. That means if I put 3 here, it would be k a 3 square by 2 minus 3 cube by 3 minus, if I put 0, the whole thing would be 0, equals to 1. That means 3 square is 9, 9 by 2, so 9a by 2 k minus 3 cube is 27 by 3 is 9, and this is equals to 1. That means, so that means it will be 2 by 9 a minus 2. This is a, so a minus 2, and so this is going to be 2a by 9a by 2k minus 9k equals to 1, and k equals to that is shown. The next question after that is, given the expected value, you have to be careful, you have to use y here. So given the expected value, so expected value is 1.75. that means expected value is also equals to the limit 0 to 3 x fx means y fy dy, which means 0 to 3 y, in place of k we can write 2 by 9 a minus 2. This is a constant. As a matter of fact, it's a good idea to just keep the k, because otherwise it looks very complicated. K, and this is going to be a minus y dy. So if we multiply, it would be k ay minus y square dy. So there is a y here, so this would be ay squared divided by y cubed. So now if we integrate, k would be in k's place, so this would be a y cubed by 3 minus y to the power 4 by 4, 0 to 3. So let's put here 3. This would be a 3 cubed by 3 minus 3 to the power 4 by 4 minus, when you put 0, 0, 0, the whole thing would be 0. So this would be 27 by 3 is 9, so 9a, let me put the k outside, minus 3 to the power 4 is 81 by 4. So this is equals to the expected value, so k equals to k 9 minus a by 4 equals to 1.75. So from here we can put the value of k. The expression k is, can be put 2 by 9 a minus 2 9a minus 81 by 4 equals to 1.75. We can just cross multiply, it would be 2 9a minus 81 by 4 equals to 1.75 into 9a minus 2. We can multiply and solve this. So by putting these values equals, we can calculate that a equals to 4, and by putting the value of a equals to 4, k equals to 1 by 9. So the next question is, for these values of a and k, sketch the probability. So let's sketch. Let me try to do it here. This is y, this is fy, this is the origin, so this is 0 to 3, so this is 3. So let's put the value here. So this would be k is 1 by 9, y, a is 4 minus y, so this is fy. So for sketching this, what we need is, first we have to put 0 here. If we put 0, the whole things become 0. Now to find this 3, if we put here 3, 4 minus 3 is 1, so this is 3, 3 by 9 is 1/3. This is 1/3. Now the shape is minus x square, y square, so the shape can be like this parabola, this portion. The next question is, write down the mode. Question number D is 3 is the mode is 3.